Welcome to homework help video number 2 over the second part of homework packet number 1, the part that starts out sequences and sigma. Notice that you need to show work on certain problems. That's because with multiple choice you could just put the answer, and since the answers are in the back, it's important that I see that you actually know how to do the problem. So please do that to get full credit. Now, there's a couple of things in general that I want to talk to you about these problems. First of all, let's just look at the first problem, number 1. It says a sub n is equal to -1 to the n over n. And it says find the second term of the sequence. When it says find the second term of the sequence, it just means that n equals 2, which means I just take 2 and put it any place that I see an n. So I say that a sub 2 equals -1 squared over 2, which happens to be 1/2. Okay, so that's all you have to do when you're trying to find terms of a sequence. The rule doesn't even have to look familiar to you at all. You just plug in numbers for n. That's all you do. Now when you see something like a recursive sequence, okay, so for example number 3, find the third term of the recursively defined sequence. So number 3, you're saying it's a sub n is equal to 5 times a sub n minus 1 minus 5, and a sub 1 equals 7. Notice that with a recursively defined sequence, you always have to have a starting point or starting points in order to use the formula, because the formula refers back to a previous term. So you have to have a previous term to start with. So if I want to find the 5th term or the 4th term, in this case the 3rd term, in order to find the 3rd term, I also have to find the 2nd term, because I can't find the 3rd term unless I know the 2nd term. So I start out with a sub 1 is 7. A sub 2, well, notice here that n is 2. So that means n minus 1 is 1. So this is a sub 2 is 5 times a sub 1 minus 5. Well, I know what a sub 1 is. That's 7. So I plug that in there, and it's 5 times 7 minus 5, which is 10. Then a sub 3 is 5 times a sub 2 minus 5, which is 5 times 10 minus 5, or 25. And so the correct answer is 25, except I think I did something wrong. Did I do something wrong? See if the correct answer is E. I don't think I worked this problem out, so it's good to make sure I didn't make a mistake. Number 3 is E, so that is the correct answer. So that's basically how you do a recursive sequence. So let's jump up to look at a couple other things that I wanted to point out. Let's see here. When it says write a partial sum, remember that means let's see, let me see which one I'm talking about here. Just trying to make sure you understand directions. Find the partial sum of the sequence, number 7. When it says find the partial sum s sub 7, that just means find the first 7, the sum of the first 7 terms. So however you figure out the pattern, you don't actually necessarily have to use a formula. You can just list the terms and add them up. If you recognize that it's arithmetic or geometric, then you can use a sum formula. But it's not necessary to always use a sum formula. D is a little tricky, but if you actually start listing terms, so for a sub n, if n is 1, then it's log of 1 plus 5 over 1 plus 6. I bet I probably should write this down as I talk, since I do have video capability here. So number 8, a sub n is equal to log of n plus 1 over n plus 6. And it says find the nth term. Let's see, find the partial sum s sub n. So in other words, you want to find a formula for s sub n. Now you might think, wow, this is going to be really tricky because this is clearly not geometric or arithmetic. It's got logs in it. It looks really bad. But whenever you're not sure what to do, start writing down some of the terms and you'll see a pattern and it really becomes pretty easy. So let me, if if you write down a few terms, I would say try it first, but if you might want to turn off your video and try it, but if you can't get it, I'll get you started a little bit. So you can turn it back on and say that. So a sub 1 means I put 1 in for n, so that would be log of 2 over 7. A sub 2 would be log of, oh, I'm sorry, that's wrong. I wrote the problem down wrong. Let me start over here. A sub n is log of n plus 5 over n plus 6. So a sub 1 is log of 6/7. A sub 2 is log of 7/8. A sub 3 is log of 8/9, and so forth. Now, how do you find the sums? Well, you add them up. So S sub 1 is just log of 6/7. It's just one term. S sub 2 is log of 6/7 plus log of 7/8. Well, what do you do with the arguments when you add logs? You multiply them. So S sub 2 is log of 6/7 times 7/8, which is log of 6/8. Now, something when you're establishing a pattern, just a tip, don't reduce fractions until later on. So because sometimes the pattern's more clear when you don't reduce the fraction. So I'm going to say don't reduce the fraction here. Don't reduce it to 3/4 or make it 0.75. Just leave it as 6/8. Find the third sum. Add up the first three terms. Find the fourth sum. You will soon find that there is a clear pattern for S sub n, and you'll be able to figure out what it is. So since the answers are in a multiple choice format, I'm not going to go any farther than that. Which of the following sums is equivalent? So number 9 is equivalent to the sum as k goes from 1 to 3 of k. Well, putting in 1 for k, you get 1 plus 2 plus 3. Put in 1 for k, then 2 for k, then 3 for k. So which other sequence would give you 1 plus 2 plus 3? Well, look at them. Look at the rules. Look at the numbers you're plugging in and see which other ones would give you 1 plus 2 plus 3 and what the sum would be. So this is my general tip for anything. Number 10 looks super complicated. It says find the sum from 1 to 21 of this sequence. It looks really messy, but I'll tell you, if you write out 2 or 3 of the terms, you'll see, oh, that's really easy. Write out, put in 1 for t, then put in 2 for t, then put in 3 for t. I think it's a t. Yeah. And see what happens and see what pattern occurs. Same thing with number 11. Number 11 is kind of a weird one. Number 11, find the sum. And it says the sum as t goes from 4 to 18 of 4. Well, where's the t? There's no t in this formula. So what happens when I put in t equals 4, or t equals 5, or t equals 6? Nothing happens. It's still 4. So that means every term is just 4. This is known as a constant sequence. Every term is 4. So the question is, how many terms do I have? I go from 4 to 18. Is that 18 terms? Is it 14 terms? Which is it? Is it either one of those? I'm going to let you decide that. You have to figure out how to count. So think about it. If I start with 4 and I end up with 18, how many terms is that? Okay, anything else that's tricky that we haven't done yet? Remember, okay, when you get to ones like 13 and 14, look for a pattern. Okay, so when I look like 5, 10, 15, 20, notice I'm going up by 5 every time. And also notice I end with 50. So when you look at the rules on number 13, so you have a bunch of different rules. You have like k equals 0 to 10 of 5 to the k. All right, well, let's plug in some values for k. First, we'd say k to the 0, or we'd say 5 to the 0. And then the next one would be 5 to the first, 5 to the second, all the way up to 5 to the 10th. Now, is that the same thing as the sequence given, 5 plus 10 plus 15 plus 20? No, clearly not, because this is 1 plus 5 plus 25, not the same. So that's not the right answer. So what you can do is, since you have the answers here, look and see which sequence, which summation notation, or which sigma notation in this case, um, gives you the correct sequence. So you don't necessarily have to be able to write a rule, you just have to be able to determine whether the rule that is given is correct for the sequence you have. So looking at number 14, you see that we alternate signs, positive, negative, positive, negative. And I did say something in the video about something that causes signs to alternate, and you'll see that -1 raised to a power there that helps alternate the signs. Notice that the coefficients 1, 5, 9, 13 have a pattern to them. Notice that the variables x to the 4th, x to the 8th, x to the 12th, etc. have pattern to them. So look and see which of those answer choices gives you the correct pattern and ends on the correct term. So you have to look at the number on the top of the sigma to see if that's correct. Number 15, find the partial sum of the sequence. So if a sub 1, this is another one that if you would just write down what a sub 1, a sub 2, a sub 3, a sub 4, up through a sub 7, and just add them up. That's probably the best way to do that problem, because that's not a formula that is a familiar formula, so there's not really a shortcut for that. Number 16, I think, is pretty straightforward. Number 17, use your calculator, list the terms, see the pattern. I don't think it's as hard as it looks. 18 and 19, a tip on 18 and 19. So when you have one like 18 and you don't have answer choices, what do? How do you write sigma notation? 16 plus 20 plus 24 plus 28 plus 32 plus 36 plus 40. Okay. What I suggest that you do is recognize that these are your terms, and they all have a term number. So term number 1, term number 2, term number 3, term number 4, term number 5, term number 6, 7, 8, 9, and 10. And ask yourself the question, what do I do to the term number to get the term? So in this case, it ought to be pretty obvious. If I look at 1 and 4, 2 and 8, 3 and 12, 4 and 16, it's pretty obvious that I multiply by 4. So my rule is, if my term number is n and my term number is a sub n, then a sub n is just equal to 4 times n. So when you do a sequence, when you do sigma notation, the rule for the term just goes right here. This is for n. I start with n as 1. I end with n as 10. That's how you do it. You have to find a pattern. How do you find a pattern? You look. Number the terms and look and think. You do the same thing with number 19. It's a little more complicated, but it's still just a pattern. You're going from 10 to 96. You can start with term number 10 if you want. Call it term number 10 and term number 96. Or you can start with term number 1 and go all the way up to whatever 96 would be, probably 86. And you can, so depending on what term number that you use as your starting point at the bottom, then that will determine what your sequence looks like, what your rule looks like, but they'll be similar. Number 20 then is more like the homework where I'll just tell you that look for a quadratic pattern on that one. And so do it like, it's a little trickier than the quadratic one I gave you in the notes, but I'm going to just say it is quadratic and try that one. Try it and see if you can figure that one out. Hopefully that's a little help with getting started on some of these types of problems, and that you'll understand what the sequence notation is telling you.